Let us continue with calculating relative atomic mass of an element, but this time round we are going to look at a practical question, a question that we can find in our practical paper. Let us see how to go about with it. So you are provided with the following: BA1, which is a solution containing 2.65 grams of M2 carbonate in 500 cubic centimeters. BA2, which is a 0.1 capital M hydrochloric acid. You are required to determine the value of M in M2 carbonate. In fact, we are still dealing with it, getting the relative atomic mass, and sometimes they ask you for the atomic mass, but in this case, if you calculate that atomic mass, you will not give its unit. So they want us to get the value of M. It is the same as getting the relative atomic mass or the atomic mass of this element M, and we are not knowing what exactly it is. So the procedure, we have to prepare 25 cubic centimeters or 20 cubic centimeters of BA1 into a conical flask, and we add 2 to 3 drops of methyl orange indicator. Titrate the solution with BA2 from the burette until the endpoint is reached. Repeat the titration until you obtain consistent results. Record your results in the table below. So let us try to work on our table here. The volume of pipette that we are using, let us use a pipette of 25 cubic centimeters. That is a 25 cubic centimeter capacity pipette. So our volume pipette, we must record it in this space without forgetting to 1 decimal place preferably. Then we go to this table here. These values here all are got from the experiment, and we have only filled them here just for the sake of our practice in as far as the calculation is concerned. So let us only fill now these parts here. Remember, these ones will not be filled for you. You will get from your experiments, just from your the practical experiment using the burette and the pipette in the process of titration. So let us try to see if these ones are already given to us for the sake of practice here. So let us finish with the table and also fill here down here. So when we are getting the volume of BA2 used, what we do is, we in this case have to subtract. So subtracting the initial burette reading from the final burette reading, this one gives us 25.40. This one gives us 24.90. This one gives us 25.10. So we are done with the table. Let us go to the values used to calculate the average volume of BA2. We are supposed to choose 2 out of the 3 values that we have got of the volume of BA2 used from the 3 different experiments. We choose 2 values, and make sure you are very keen in this case. Look at 2 values which are really so close, what we call consistent values. So if you see this and this, the difference is about 0.5 cubic centimeters. This is much. Look at the difference between this and this. The difference is about 0.7 cubic centimeters. The difference between this and this is only 0.2 cubic centimeters. So we can pick this value and this value here. Someone will get mistaken, looks at this 25 and looks at this 25 and say, oh, I've got what? 2 values which are consistent. No, you have to physically subtract. Get the difference by subtracting, and then you see the difference that you're having. The one with the least, the 2 values with the least difference in this case are the best values to choose for calculating the average volume of BA2 in this case. So we are choosing 24.90 and 25.10, and we write them here, 24.90 and 25.10. Then let us get the average of these 2. It is equal to 24.90 plus 25.10, and we have to divide by 2. So this one gives us 24.90 plus 25.10 gives us 50.00, and if we divide by 2, we get our average volume being 25.00. So the unit is cubic centimeters. Mark you this. Never leave out the unit when you have got the answer in this case. you need to record the unit because you are dealing with volume. Now, before we can go to answer any question further, let us go ahead and we get our data. We collect the data. It is very important in this case. So let us collect our data here. That one will help us in our calculation for the sake of easing our calculation. And where do we collect our data from? We start from the beginning part here, as I had already told you earlier. Then we go to the first sentence under procedure. And then we go to the average volume here. This is where we collect our data from these 3 points here. Let's start from the first part here. We have been given BA1, which is a solution containing 2.65 grams of M2 carbonate and it is in 500 cubic centimeters. So the concentration is 2.65 grams per 500 cubic centimeters. It is not per liter. It is very clear here. Then let us look at BA2. BA2, which is a 0.1 capital M hydrochloric acid. We are done with the introductory part here. Let's go to the first line under procedure. Prepare 25 or 20 cubic centimeters of BA1. BA1. So its value of volume is here. Which one have we used here? It is 25.0 cubic centimeters. That is of BA1. So we add the volume here. It is 25.0 cubic centimeters. And we are done with this. We now jump over to the average volume. The average volume of BA2, its volume is 25.00 cubic centimeters. So this is our side work. It is not marked. It is just our side work. We are going to use it for simplifying our calculation so that we get what to use very easily from our collected data. So let us try to see the questions now. Allow me use this upper part here. I believe that we have already seen this all and we have already collected our data, which we are going to use very easily for our calculation. So let us see the questions that accompanies the whole of this information here and the procedure that we have followed up to the table. So even if I do away with some of these parts here, we have all that we need in our data, which we have collected there. So A, the questions now, calculate. Let me use a mark of a different color. Calculate the 1 moles of hydrochloric acid that reacted. 2, calculate the moles of M2 carbonate that reacted. Then B, determine the moles of M2 carbonate in 1 liter of solution. Oh, we shall see what this one is all about. C, part 1, calculate the molar mass of M2 carbonate. Then part 2, hence determine we are now on the rationale of the whole of this experiment, hence determine the mass or let us use the value of M in M2 carbonate. Given that carbon equals to 12, oxygen equals to 16, and hydrogen equals to 1. So we can now do away with this part down here, because we have all the information. We have seen how to go about with what is in the table. So let us try to see how to go about with the calculation now, since we have collected our data very clearly up here in blue. So in part A, Roman 1, we are supposed to calculate the moles of M2 carbonate, the moles of hydrochloric acid that reacted. A Roman 1, we get the number of moles of hydrochloric acid that reacted. So since we have the molarity and then the volume of hydrochloric acid that reacted, we shall say 1,000 cubic centimeters of hydrochloric acid solution contains, what's the value of molarity we have been given? Is it 0.1, and we use mole in full. And then what of the 25.00 cubic centimeters, the volume of hydrochloric acid that reacted? How many moles of hydrochloric acid are there? So it contains, we cross multiply 0.1 times 25.00 over 1,000, and the unit is mole. So it gives us 0.0025 mole. So try to calculate, well, 2.5 over 1,000 is 0.0025 mole. Then we go to Roman 2. We should also determine we calculate the moles of M2 carbonate that reacted. Where is the problem? The problem is M. We don't know what M is. So we are going to borrow the number of moles from hydrochloric acid using the mole ratio, which comes from the equation for the reaction. So we have to write the equation for the reaction between M2 carbonate solution and hydrochloric acid. And we get, in this case, M chloride. Correctly, we need to use the valencies. So the valency of carbonate is 2, and this 2 is here. The valency of M, since there is 1 here, we are not seeing this carbonate bracketed. It means the valency of M is, in this case, the valency of M is 1. So we have M chloride produced together with water and then carbon dioxide gas. And we balance this equation. There are 2 atoms of M here. We multiply M chloride by 2. The number of chlorine atoms are 2. We multiply hydrochloric acid by 2. Hydrogen atoms are 2. Here there are 2. Oxygen atoms are 3. This side also there are 3. Carbon atom, 1 on the product side and 1 on the reactant side. Our equation is balanced. So the mole ratio is 1 M2 carbonate to 2 hydrochloric acid. Now let us try to see. We are, in this case, getting the number of moles of M2 carbonate that reacted. So what do? We take M2 carbonate to our right hand side, and we start with hydrochloric acid, whose number of moles we already know. So we start with what we are seeing from this equation, the stoichiometry of the reaction, that is the number of moles of each of these reactants here in the equation or from the equation. So we say 2 moles of hydrochloric acid reacts with 1 mole of M2 carbonate. And then what of this number of moles? The 0.0025 mole of hydrochloric acid, in this case, it reacts with, and we cross multiply 1 times 0.0025 over 2 mole. And what do we get in this case? It will be 0.00125 mole. That's the number of moles of this M2 carbonate that reacted. And then let us go ahead and we get the molarity. That's the number of moles in 1 liter. This is the molarity. So this is the number of moles which is in this volume here. We say 25 cubic centimeters of the solution of M2 carbonate contains 0.00. The volume is, the number of moles 0.00125. The unit is mole. And then what of 1,000 cubic centimeters of M2 carbonate solution. So it contains 0.00125 times 1,000, and we divide by 25. The unit remains mole. The chalkboard is, the whiteboard is not reaching up to there. So let us try to get our answer in this case. The 0.00125 times 1,000, and we divide by 25. So we have got 0.05 capital M. That's our molarity. Next is calculate the molar mass of M2 carbonate. The molar mass of M2 carbonate, that is our C part 1. The molar mass of M2 carbonate. That's the mass of 1 mole. We have the molarity. This is the mole. In fact, in this case, this is the number of moles in 1 liter. That's our molarity. So, with the molar mass of M2 carbonate, we are supposed to compare the molarity with the mass, but the mass should be in grams per liter, which we don't have. This is the mass in 500 cubic centimeters. So, let's convert to the mass in 1,000 cubic centimeters. And we say 500 cubic centimeters of M2 carbonate contains 2.65 grams. And then what of 1,000 cubic centimeters of M2 carbonate? So it contains, and we cross multiply, to be 2.65 times 1,000 over 500 grams. And what do we get here? It is going to be 2.65 times 1,000 over 500. And we have exactly 5.3. This is the mass which is in 1 liter. So we are going to compare this with this, and we get the mass of 1 mole. And here we say that 0.05 mole of M2 carbonate weighs 5.3 grams. And then what of 1 mole? Molar mass, the mass of 1 mole of M2 carbonate. So this one weighs, it will be 5.3 times 1 over 0.05 grams. And let us see what we have here. It is giving us exactly 106 grams. That's the mass of 1 mole. And finally, let us look at the relative atomic mass of this element, M. That is the value of M in that compound M2 carbonate. Let me use this part here finally. That is our Roman 2. We use this part here, Roman 2, and we shall have to equate the whole of M2 carbonate. We equate it to the mass of 1 mole, which is 106. So it will be 2 times M, which is 2M, plus 12 plus 16 times 3 will give us 106. So it is 2M plus 16 times 3 is 48 plus 12 is 60, will give us 106. So 2M is equal to 106 minus 60. Let me use this part here. So 2m is equal to 46, and m is equal to 46 divided by 2, and m is equal to 23. So the relative atomic mass of this element is 23. That's the value of m in M2 carbonate. And that is how we can get the value of m, which is the same as the relative atomic mass of this element.
Okay.
So thank you so much. This is Step Talks.